8051 Microcontroller based system. CPU external RAM ROM I/0 non-internal RAM ROM I/0 ports in CPU. Microcontroller a controller computer is on chip. On chip RAM ROM I/0 porter time serial controller. Example Motorola 6811 Intel 8051 ATml32. Microprocessor versus microcontroller. Microprocessor CPU is a standalone RAM, ROM, I/0 timer are separate. Designer can decide one amount of ROM, RAM and I/0 ports. Expensive. General purpose. Microcontroller CPU, RAM, ROM, I/0 and timer all on a single chip. Fixed amount of on-chip ROM, RAM, I/0 ports. Not expensive. Special purpose. C-based embedded system. Special purpose computer system usually completely inside the device it controls. Has a specific requirements and performance predefined tasks. It reduction cost compared to general purpose processor. Example embedded systems. 8051 CPU operation. Features pin diagram block diagram. 8051 microcontroller. Intel introduced 8051 referred as MCS 51 1981. 8051 is a 8-bit processor. The CPU can work on only 8-bit of data at a time. 8051 widely popular after allowing other manufacturers to make and market any flavor of the 8051. Features of 8051 8-bit microprocessor, 4 KB internal ROM, 128 bytes internal RAM, 4 8-bit I/O ports, 32 lines, 2 16-bit timers by counters, 1 chip full duplicate word and serial communication, 5 vector interrupts, 2 external, 3 internal, timer not time on serial. On chip clock oscillator, bit address bus, 64 KB external code memory, 64 KB external data memory, 16-bit program counter to access external code memory, and a 16-bit data pointer access external data memory, 128 user defined flags, 32 general purpose registers each of 8 bits, KTALI and KTAL2. 8051 has a on-chip oscillator but requires an external crystal to run it. A quartz crystal oscillator is connected with 2 inputs and the time it started with KTA22 pin 18. The quartz crystal oscillator also needs 2 compacts of 30 PF. The original 8051 operates at 20 MHz. KTAL1, KTAL2. If you are frequency source, then a crystal oscillator such as TT2 oscillator, it will connected to KTAL1. KTAL2 is left unconnected. RST reset pin is a input and in active high, normally low. Upon applying a high pulse to this pin, the microcontroller will reset and terminate all activities. This is often referred to as power on reset. Activating a power on reset will cause all values in register to be lost. EA is a external access input pin and must be connected to use a CHD. 8051 family members all come with on-chip ROM to store program and also have a external code and data memory. Normally EA pin is connected to VCC internal access. EA pin must be connected to CLLD to indicate that the code of data is stored externally. PSEN and ALE. PSEN program store enable is an input pin. This pin is connected to OE pin of the external memory. For external code memory, PSELT equal to 0. P external data memory, PSWL equal to 1. ALE pin is used for multiplying the address and data. I by O port pins. The 4 8-bit I by O port PO, P1, P2 and P3 each uses 8 pin. All the port upon reset are configured as output, ready to be used as input ports by external device. Port 0. Port 0 is also designated as ADO ADT when connecting an 8051 to an external memory. Part O provide both address and data. The 8051 multiplexer address and data through port 0 to save pins. ALE is PO0 has address or data. When ALE equal to 0, it provides data D0 minus D7. When ALE is equal to 1, it has address A0 minus A7, port 1 and port 2. In 8051 based systems with no external memory connection, both P1 P2 are used as simple I by 0. In 8051 based systems with external memory connections, port 8051 needed the PO to provide 16-bit address for external memory. P0 provides the lower 8 bits in A0 minus A7. P2 is used for upper 8 bits of 16-bit address, designated as A8 minus A15 and connected be used for I by 0. Part 3 Serial communication, external interrupts, timers, read by write signals of external memories.